Hi, welcome back. This is Rakesh Naik. Today we are going to discuss about Introduction to Dynamic Programming. But before we start, a small information I'd like to say. In this channel, we produce every video in 2 different languages. If you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. But before we start, a small information I'd like to give. In this total session of the video, I kept 2 check your progress. To check your understanding, I kept 2 multiple choice questions. Whenever the question appears, pause the video, choose your answer, write it in your comment and then proceed. At last, we are having the solution for these multiple choice questions. So, let us start. Basically, dynamic program is normally applied for optimization problem. What is an optimization problem? A problem which can be either maximized or minimized. And this technique is developed by Richard Bellman in the year 1950. Basically, dynamic programming is a bottom-up approach for solving any kind of problem. It means we first attempt to solve the simplest subproblem of the given problem, and this problem will be solving under the given constraint, and gradually we'll handle more and more complex subproblem using the earlier result that we have already computed. And in this method, each subproblem is solved only once, and the result to each subproblem is recorded in a table from which we can obtain the solution of the original problem. Now let us check your understanding. Read the question, give the answer in a comment. Let us see what are the steps that we use for dynamic programming. Basically, we develop a mathematical notation that can express any solution and sub-solution for a given problem. Then recursively define the value of an optimal solution. Then compute the optimal solution from the computed information that we are having. And by using bottom-up technique, compute the value of the optimal solution. Dynamic programming is based on the principle of optimality. What is that? The principle of optimality states that for an optimal sequence of decision or choices, each subsequence of decision or choices must also be optimal. Now here you can note that we must be aware there are many situations in which the principle of optimality may not be applicable. So where it is not applicable, the principle of optimality may not be true, especially in the situation where the resources uses over the subproblem may be more than the total resources used over the whole, and where the total resources are limited and fixed. We'll be taking an example and try to understand this, how that everywhere the principle of optimality is not applicable. So the principle of optimality is not universal, especially when resources are limited and fixed. Let us take an example here. The world record for 400-meter race is 43.03 seconds. In order to complete 400 meters in 43.03 seconds, it means he has to cover 100 meters in 10.75 seconds. It means 10.75 seconds supposed to be the best that can be achieved for a 100-meter race. So is it that true? The answer is no. Because Usain Bolt in 2009 won 100-meter race with the timing of 9.58 seconds. If we take 100-meter race is a sub-problem of 400-meter race, it means in this particular situation, dynamic programming cannot be useful. The reason being that the resources that we have used is more in the sub-problem than in the main problem. Now let us pause here, check your understanding. Write your answer in the comment box given below, and the actual answer will be discussed at the end of the video. Now let us try to recollect everything. Dynamic programming uses bottom-up approach. Many decision sequences are generated and all overlapping sub-instances are considered. The duplications of solutions are avoided and split all its input at every possible split point rather than a particular point. We determine the optimal split point only after trying all the split points, and there is no special set of feasible solutions here. It considers all possible sequences in order to obtain the optimal solution, and it uses principle of optimality to get all its solutions. Let us take one more example, binomial coefficient. Now, when we are using binomial coefficient, we use this formula. Then how it uses? Now, we have this one value. We take these two and find the value of 2. Then we take the value of 1 and 2, find the value of 3. 1 and 2, then find the value of 3. Similarly, 1 and 3, then find the value of 4. It means we are having some base condition, and by using the base condition, we kept on generating our further results. So let us see its application. So these are the application for which we apply dynamic programming. And the solution for the first question is dynamic programming, and the solution for the second question is principle of optimality. I hope you understood. If you understood, give me a like and share among your friends. In our next video, we are going to talk about some more application of dynamic programming. See you then. Take care. Bye.